Section 9.5, compositions of inverse functions. I'm going to do math blindfolded. Here we go. So notes, pretty sure it says the property for composition of inverse functions is that if f of x and g of x are inverse functions of each other, then when you compose them together as either f of g of x or g of f of x, because it doesn't matter, then it should equal x. Or simply put, if you compose a function and its inverse together, your answer should simplify to be just x. If your answer is anything other than x, then the two functions are not inverses of each other. So in practice then, what that means is compose these two functions together, and if the answer ends up being x, then we have inverses. So to test that, it doesn't really matter which way you do it, so I'm going to do it as g of f of x will equal what? Well, let's find out. First of all, I'm going to take f of x. F of x is just 4x minus 6. Since all I'm doing is I'm plugging in x into the function, well, it's just 4x minus 6. So then when I simplify this, this is g of 4x minus 6. Because again, f of x is 4x minus 6. Then, now 4x minus 6 is my input that I'm going to plug into g. So anywhere I see the x back at g over here, I'm going to replace it with 4x minus 6. So that's going to look like this. 4x minus 6, and then the rest of the function, which was, I'll write in blue, plus 6 over 4, and then now I'm just going to simplify this. So there's nothing in front of the parentheses to distribute. I can just ignore these parentheses, but just keep in mind, you got something in front of parentheses, you got to distribute it. So then I've got a minus 6 and a plus 6, those things cancel. 4x over 4, well, if you do that, then it just equals x. So then ultimately, g of f of x equaled, it simplified down to just x. Well, that's it. And yes, these are inverses. Yes, they are inverses. Okay, same thing, different functions. So again, it doesn't matter which way I do this. I'm going to do this as f of g of x, and I want to see, does this end up equaling just an x? So first of all, g of x is 4x plus 4. So I'm going to plug in 4x plus 4 into f. So then anywhere I see an x in f, I'm going to replace it with 4x plus 4. And the rest of this I will do in blue again. So then there was the 1/4 that was in front of the x, and then there was the minus 1 that was after the x. So again, I've got f of 4x minus 4. I've replaced my x with 4x minus 4. Now I'm going to need to distribute and combine like terms. So 1/4 of 4x is just x. 1/4 of plus 4 is plus 1. And I still have this minus 1 from over there. Well, plus 1 minus 1 cancel. And sure enough, I have that my answer just equals x. Therefore, that once again, yes, these are inverses. One more example. So, again, it doesn't matter. You can take your pick however you want this to be. I'll once again do f of g of x and see what that ends up being. So g of x is the square root of x plus 1. Well, now then I'm going to put a square root of x plus 1 anywhere I see an x. Well, there's just only one x and it's squared, so then That's going to look like this. Square root of x plus 1. And then this part here in blue represents the part that is actually the function f. And all the function f did is take x and square it, so I'm taking square root of x plus 1 and I'm squaring it. Well, when you square a square root, that cancels the square root and the squared. So this all cancels, and now I just have x plus 1. There's nothing left to simplify. Since this does not equal x, then no, these are not inverses of each other. So it doesn't matter which way I do my composition here. If I do it f of g of x or g of f of x, they won't work out necessarily to be the same thing. But the more important thing is it doesn't simplify to just x. So since it doesn't simplify to x, it's not an inverse of each other. Alright, that's it.